if f of x and y equal x tan inverse of x plus y squared, find the f dx and the f dy. So this is a tan inverse problem, trig inverse problem, and there's a need for us to know the trig inverse formulas before we'll be able to solve problems of this form. Well, these are the basic trig inverse identities you need to know. Yes. So d over sine inverse of u equal u inverse, u prime all over 1 minus u squared, in which u prime is a derivative of u. Cos inverse of u equal u minus u prime all over 1 minus u prime, which is square root. And tan inverse u equal u prime all over 1 plus u squared. Sec inverse u equals to u prime all over absolute value of u, which means the value for u should be positive. Whether you get a negative, it should be positive. So square root of u squared minus 1. And for cosec inverse u equal to minus u prime all over absolute value of u, square root of u squared minus 1. And cot inverse u equals minus u prime all over 1 plus u squared. So these are the basic trig inverse identities that you need to know for us to be able to solve problems. Mind you, basic trig identities. So we are going to apply this in partial derivative problems like this. So let's continue. So we have to find the partial derivative of f here with respect to x and then with respect to y. So we know the f, the x is going to be, we are differentiating with respect to x, and here we have two terms. We have this term right here and then x here, which stand alone. So we are definitely going to use the product rule. And for the product rule, simply mean if we are to find the derivative of function f multiplying by g, we are going to find the derivative of one leaving the other plus derivative of the other one leaving the other one, right? So that's what we are going to do here. So now let's find the derivative with respect to x. With the first term, which is x, this is going to give us 1 multiplied and leaving the rest, which is tan inverse of x plus y squared, right? Then plus leaving this one and differentiating the other one, so we have x. And tan inverse, for us to differentiate tan inverse, we know that, where is your tan inverse formula? So this is our tan inverse formula, right? So keep that in mind. So we first differentiate what is here, then divide it by 1 plus what is here squared, right? This is our u. In this case, this is our u. And we are differentiating with respect to x, right? So multiply. Differentiating this with respect to x, we have 1, right? This doesn't have, it have no x term, so it goes 0. So all on 1, which is 1 plus our u squared, all of these squared. So x plus y squared, all squared. So we can further simplify this as, so we have tan 1 by tan inverse of this, the same as tan inverse of x plus y squared plus, then x by 1 is the same as x all divided by 1 plus x plus y squared all squared, right? So that is it for the f dx. And now let's find the f dy. For dx, for the f dy, looking at this, we cannot use the product rule in this case because we have only y term to be here, no y term here, right? So we just leave the other one as it is and focus on where we have y term. So we are going to differentiate this, and we know that differentiating this tan inverse formula, we're going to get u prime all over 1 plus u squared. In this case, this is our u. So let's proceed. So u prime with respect to y, this contain no y value, so it goes 0. So we have 2y, right? So we are going to get, let's leave x as it is. So multiplying 2y all divided by u from the formula, right? All divided by 1 plus u squared. So we have 1 plus u squared, which is x plus y squared, all squared. So we can further simplify this as x multiplying 2y gives us 2xy all on 1 plus x plus y squared all squared. So that is for the f dy.